Well, welcome to this dialogue about the law of sines. And in this video, we're going to tackle something that most students find to be fairly simple. And it's going to be just an introduction to the law of sines and when do we use it. So I hope that you find it simple as well. Let's jump in. So let's jump in. All right. What is the law of sines? Well, the relationship we know as the law of sines can be derived from an oblique triangle. And oblique is kind of a funny word. It is nothing to do with a six-pack abs. It really just means a triangle that does not have a right angle. Okay, so it's a class of triangle. Anything that is not a right triangle is classified as an oblique triangle. Okay, so in this oblique triangle, before we do anything else, I want to remind you of a couple of things. Notice that my side lengths are labeled A, B, and C, and my vertices are labeled A, B, and C as well. Now, if you are observant, you will notice that the vertex that is opposite the side length has the same letter. Just one is capital and one is lowercase. And that is true for all three of our side and vertex pairs. And that is convention. Even if it is not labeled that way, you can make that assumption. So we'll probably use that in a little bit. Now with this oblique triangle, we are going to actually drop an altitude. An altitude is nothing more than a line that connects one vertex with the opposite side and forms a right angle with the opposite side. And an altitude also serves as the height of the triangle if the side that it's connecting to is the base. Okay, so let's focus on the right triangle that occurs on the left. Okay, and I'm talking about this triangle in orange. Okay, if I'm looking at that triangle, what can you say about the sine of angle A? Sine of angle A. I think you should be able to say that that's the opposite side over the adjacent side, or H over B. And if the sine of A is side H over side B, I can go and solve for the height of the triangle by saying that that is B times the sine of angle A. Okay, now let's put that right triangle away and look at the other right triangle that's formed, the right triangle that's on the right. Is that a right triangle squared? I don't know, the right triangle on the right. Okay, that's silly math humor, but you know. Okay, so in this case, we're going to focus on this blue right triangle. We know it's a right triangle because of this notation. Even though it's on the outside, that means that this is a right angle as well. And in this case, we're going to say, all right, what can you say about the sine of angle B? And if you're looking at that carefully, you should be able to say that the sine of angle B is H over A, or opposite over hypotenuse. Okay, and so in this case, we'll go ahead and solve for the height by saying H is equal to A times the sine of angle B. Now notice that when I did this, I ended up with two different expressions that are both equal to the height. And that's useful because now I can set those expressions equal to each other. Okay, so now if they're equal to each other, I can manipulate them a little bit, and that manipulation is going to lead us to the law of sines. First thing I want to do is isolate the side length B on the left-hand side. So I'm going to multiply both sides of the equation by 1 over the sine of angle A. Okay, and when I do that, notice that this sine of angle A and this sine of angle A will cancel each other out. So the left-hand side will just be B, and the right-hand side will be A times sine of angle B all over sine of angle A. All right, so now let's multiply both sides by 1 over the sine of angle B. All right, so when I do that, notice on the right-hand side, I'll get this sine of angle B and this sine of angle B will cancel, and I'll end up with B over the sine of angle B is equal to A over the sine of angle A. Okay. Well, what about angle C and side C? Well, if I flip this triangle around and look at it in another orientation, I can get the same relationship happening there. And that leads us to what is known as the law of sines. And the law of sines just says that those pairs are proportional. The length of side A over the sine of angle A is equal to the side length of B over the sine of angle B, which is also equal to the side length of C over the sine of angle C. So that allows us to do some things that we were not able to do prior to knowing this law. And in fact, we will be able to solve triangles that are oblique triangles now. Aren't you excited? Because you couldn't do that before. We can't use the Pythagorean theorem because Pythagorean theorem only works with right triangles. Well, we're dealing with obliques now. When is the law of sines used? This is clutch. You need to know when to use this tool. And really, it's key when the information that you're given about a triangle includes at least one side length as well as the opposite angle measure to one of the given side lengths. So I need to have a side length and the opposite angle measure. I need a pair for me to use the law of sines. If I don't have a pair like that, I can't use the law of sines. Two of the cases that this happens with, when I have two angle measures, like these two, like z degrees and x degrees, and the length of the included side, that's an angle side angle case. Or I've got two angle measures, there's angle z and angle x again, and the length of a non-included side. Now, if this side is the included side, then the non-included side could either be this side or that side. And in either case, this is considered an angle-angle side triangle. Okay, and there is one other case where we might use the law of sines as well, but that's going to be tackled in the next video. And that's when you have a side-side angle situation. And we'll talk about that next. We're not going to get there quite yet. So let's give it a shot.